Hello, students. So, do you have any doubt from lecture number 21 to 24? This is the control theory part. Okay. Any doubt from the tutorial problems? Okay. So tell me the doubt.
Third chapter, the last question that you have given, 13th one.
I'm not able to hear. Okay. Louder, please. So your voice is not clear. Either you can write in the chat box or problem 313. Okay. Problem 313 torque equation. Okay. Just a minute. Let me see. Yeah, okay. Yeah, so in this problem B313, okay. So here is some extra thing is given. So at the end you have like this. So this is theta, and here you have a gear, right? So you have a gear here, and then here something like this one. So it says N, and then there is another gear here, and this is say tau, and it has mass moment of inertia, which is equal to Jn, and then you have theta. Okay. So what you have to understand here is how they are related. So it's important to know the mechanics. So what is extra? This side we have done already. So this side we have, the plus, minus, and that will be back EMF will be there. There will be some resistance, it will be there, and there will be some inductance as well. So like this, right? So we have those things like that. Yeah. Okay. So this part we know already. So how in the lecture also I have covered that already. But in that case, you had only till here. Yeah, so it's a theta m here, this is theta here. So now extra layer has been added here. You have to write the equation, and how you will write? So first you have to separate this portion out. Okay, so you have, in that case, will be something like this. So you will have, okay, so this is called JL probably here. Yeah. Okay, so this is JL and then theta. Yeah. Okay, now remember that the common thing between this and this is actually force only, right? So there is a force which will be acting if, right? So, and because of that, the torque will be there. So this is R This one is R1, is a radius, and force is common, and hence the torque will be different, right? Let's say for this one system, we have tau 2, which is equal to F times R2. This is the common force between the two gears. This will be given by JL theta double dot. Yeah. So this we know, given the torque and how the theta related with this one, right? So this one we know. So this equation we have to use. Now look at this one. Yeah. So this will have Jm here, and then the rotation is theta m, and then we have another torque, the gear here, and that gear has radius r1, but force is the same, right? So, and the force will be in opposite direction. So let us say, if looking from this side, if this motor is driving it anti-clockwise, there will be a reaction because of this, because this is a load for this one, right? So it will resist basically. So the force which will apply here, the torque which will apply here will be clockwise in that case, right? So because it's a load basically, so this is going to act against the original torque which is being provided by this one. The original torque, let us call is tau, okay? And this torque, this one, let's call it tau 1. So that will be, this is anti-clockwise, but this will be clockwise. Let's call it tau 1. Okay. Now write the equation. Equation will be tau minus tau 1, which is the actual, the total torque acting on this one. And this is going to act, and equation should be Jm theta m double dot. That's what it will be, right? So this relates to this one. How? There tau 1 is equal to F, same F we have, and R1. R1 is the radius of this gear. So this is how both are related actually. So what we get here, actually tau minus FR1 equal to Jm theta m double dot. So this is another equation. This is FR2 equal to JL theta double dot is one equation. So let's say call this is 1, this is 2. The relation between this and this, you can see basically how they are, right? Or from there, you can also get, next thing will be to actually the simplification and all. Yeah. But also given for you that theta m by theta is also given, right? So relation is n equal to theta over theta m. Yeah. So n equal to theta over theta. This is theta over theta m, right? Okay. So remember, I think there is some problem here. I mean, typically when n you have, so the velocity will decrease. So let us say the okay, what is the meaning of that? So this is R1 here, this is R2 here, right? Okay, so the torque, when you say torque, tau 2 equal to FR2 and tau 1 equal to FR1, and hence tau 2 over tau 1 will be R2 over R1, right? So simply we have tau 2 over tau 1 equal to R2 over R1. Now, the whatever shown here, the gear ratio, when you say like this one, then it has little bit opposite meaning than what we think. But we will use just this equation basically, rather than going to details. So what is here? Theta of this one, let us say this one has the this moves by theta m. So the distance traveled by this has to be equal to distance traveled by this one, right? So because both are engaged. So you have theta m multiplied by, right, theta r1. Theta m multiplied by r1 will be the distance traveled. Should be equal to, for this also, theta times r2, right? And what you get from here is theta over theta m, theta over theta m equal to r1 over r2, right? It says r1 over r2, right? So is m, but the way it's drawn, it looks like this m, this is bigger. So number of gears, right? So the number of teeth, number of gears, that will be more in this case, right? So that means actually the looking at the picture, it looks like m should have been theta m over theta equal to n basically, but you forget that. Okay, so just we will use the equation which is given here, and it says theta over theta m equal to r1 over r2 is equal to n, and you put this value here and get tau 2 over tau 1 equal to 1 over n. So this you get it from here, right? Yeah. And rest you have to use like this one now. Okay, so then how will you use? So the equation we have is this. So tau 2, you can write it here. Tau 2 is equal to 1 over n tau 1, right? So where this equation we can write. So this is equation number 3. Okay. So now see which all equation we have. Okay, so I'm going to delete here. So we have now we have one equation. Okay, so if we can now, since this is in terms of n, so this we don't need it, we just need this one. So you write tau 2 equal to jl theta double dot. Okay, and then the second equation we have is this one, and this is tau minus tau 1 equal to jm theta double dot is done, and third equation is this, tau 2 equal to 1 over n tau 1. Okay, and then there is another equation, so that was theta over theta n, or theta equal to theta m times n. This is another equation, and then all other equation here, whatever you have, you will use it, and then you can solve it. You got it? So main thing here is these equation basically are main thing here. Yeah, so you can replace, for example, this is equal to this, you can say say here. So you can replace here. So you get tau from this equation we got what? So tau 2 equal to this, so you get 1 over n tau 1 equal to jl theta double dot, and hence tau 1 you will get n jl theta double dot, so you get that. Now this equation you will put it here, so you get tau equal to n jl theta double dot plus jm theta double dot, or equal to n jl plus jm theta double dot, right? So you have this equation here, so this relates a tau, where tau is the torque of the produced by the motor now. Say, or this relates tau with funnel theta here automatically. So all these things are taken care of automatically now. The rest you have to write the other equations, and those equations are as per the question we like as per for the motor we have derived, right? So same thing will be applicable there. Okay, so please solve it. So because it's better to solve yourself. But this is the main thing here. This is a one extra thing. So if you have, if you draw the, what I would recommend is always draw the free body diagram. So all the forces you see there, automatically you will know that what you have to do, and it makes sense that whatever torque is here, it has to drive both of them, this also and this also, and hence this equation J, L and J both should be there, and hence you have that. Okay, just a minute. Okay, so B35. Okay, just a minute. B35. Okay. So as I told you earlier, this course will be a little bit tougher than the previous portion, because here we have all kinds of problems. So not only vibration problem, but it will have rigid body dynamics and all coming into picture. Yeah. So hence the theory of machine, how you derive the equations and all, the basics of all those are only Newton's laws of motion only. But you understand that it's very important that you should have the grasp of the Newton's law of motion. Very important. If you know that, you will be able to do very easily. Okay. So here, although statement looks like it's a high school thing, but actually, you can apply if you can apply in difficult problems. I mean, not I would say difficult. It is a matter of understanding basically. And then you should be able to solve it. Okay, so I think practice is needed, and you will be able to do it. So I'm going to solve this one. So it means tell you the equation how to solve it. So uh, the so I have not seen the example problem how they have solved it, but I will solve my way. Okay, so always there is a your preferred way of solving it. Okay, so this is a bar here, and this theta is very small, and here you have point G, which is a center of gravity. Length from here to here L, from here to there is L. Okay, and this is moving with in this direction also. Theta can also move, and there is a force U given. So U is force basically. Remember, this is a force. Okay. Um, so distance from here to here is x. Okay, from the baseline, and this is how the mass is m for the bigger mass, and mass of inverted pendulum is m evenly distributed. So this is m and evenly distributed. So this is what this is. Okay. So first of all, remember that I will just write f equal to u, so that you can. I will just take f and in my equation so that you are not confused, because use also used as displacement. So mechanism we have used a lot. So this is confusing. So you just write F. Here U means the input basically. That's what. Okay, now first of all, understand that this inverted column, the inverted pendulum, is very important basically. Yeah, so even when you walk, basically we are live inverted pendulum only. Yeah, so our two legs basically they balance, and you can balance with even with one leg, right? So you know what to do, because so we have learned. So it is not that easy. You have to ask the babies, right? Those who are less than 1 year, they will tell you how difficult it is. But the idea is to like our brain works in sync with our legs basically to balance it. Not only legs but hands also. So all those things so synchronized. So we have the control system in built, and basically we are able to balance anything, right? So if you have something like this, you have, and we are able to balance, right? So just for a little bit, I mean, typically the big one is easier to balance, right? So big stick or something, right? So all those things are basically the we know, our muscle know basically how to move, so that is always this is in vertical position. Inverted pendulum is the same thing. The challenge here to keep this bar vertical. How? By moving this one. So let's see the planar problem, and you want to move such a way that it remains vertical. Before we actually design this kind of system, first we have to understand the system, how it behaves, what the equation, and hence you have this in this chapter. Later on also, uh, you can in fact design something which keeps like this one. In fact, I remember in Michigan State University there was some talk where somebody was talking about the motorcycle which will like a balance is safe, like you don't have to go and park, just leave it there, it will balance by its own, like that. So this kind of thing. So anyway, so this how to solve it. So again, three body diagram very important. It's a three body diagram always. Yeah. And my way of doing is like this. I will first separate them out. Okay. So first thing would be for the big mass, we have like this. So M. So there's a hinge here, and hinge, at the hinge there is no moment, but it will take some force basically, right? So this bar will have two forces. Let us say this is called Ry and this is Rx, right? Because there is a pin here, and 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 what you see in the middle, you have mg like this. This is going here. So in this case, remember, inverted pendulum, gravity is important. Yeah. So if there is no gravity, there is no pendulum, as you know, right? So basically, it's even if it may not be given that consider z, but still you have to consider, because pendulum means gravity has to be there, otherwise no pendulum. Actually, yeah. So gravity is given. So mg, which is acting downward, yeah, and here you have the theta like this one, and then is there any other forces on this one? There is no other force. Yeah. So and only thing is we know how the point is. This point is moving. First thing is this one is x. This is moved by x. This point, and from here it also has moved. And how much it has moved? This has moved by L times theta. L is distant from here, and theta is very, very small, right? So L times theta is the water move. So this point has x plus L theta displacement. Right? So this much is the, yeah. I have written this one, although it's not required here. I'm just working out the forces only. But the forces, what do we see in this case is since it is a vertical and it is not very much moving. Yeah, so the vertical location remains the same. Basically, that really means that there is no vertical acceleration, and hence you can say Ry minus mg equal to 0. So simply you get Ry equal to mg. So this tells you here we are getting nothing but mg only, because whatever the force is going applying here, the same force has to be there. So mg goes like this. Now Rx, what is Rx here in this case? Now Rx value will come from here. Which all forces are there? Applied force only Rx. So we have Rx, and Rx has to be equal to the whatever the here the displacement m, a small m, and multiplied by the acceleration, right? And this acceleration will be simply the displacement, the double dot of that. What you get? X double dot plus L theta double dot. Why? Because this is the displacement, and hence the total force Rx has to be equal to MA, where A is equal to X double dot plus L theta double dot. L is a constant, right? So hence you have this equation. Yeah. So you get R value of Rx as well. Yeah, and then you know that if it is if the force is applied like this one, and hence the M will be like this one, and hence your here the force in this case will be Rx simply, where Rx the value is like this. Okay. So we got this one. So this is clear so far, right? Okay. There is one more equation we will get here, and what is that equation? We have to see the rotation part, right? So this is also rotating. So Newton's law of motion we can also apply in the rotation, right? So you consider about G. This is a point G, right? So about G, you can see the how it is working. Yeah. So about G, first will be the, let us say, J. Yeah. So Jg is equal to, now this is a theme. This is distributed. Typically, this is given by, this will be given by half m L square. Typically, you will see a bar of length L, total mass m, the moment of inertia about the center of mass of this one, or from the middle point is given by this, right? So where L equal to 2L, right? So because this is L here, so you know 2L, so equal to 12 m 4 L square, and hence you get 1 over 3 mL square simply, right? So this is the about middle point, about this one, right? Okay. Now, what is total torque acting? Total torque, total moment about G has to be equal to Jg times theta double dot. So that's the equation. Yeah. So this is second law of Newton's second law of motion. Total moment in this case, if you see, will be now clockwise is positive for us in this case. Right? Theta is going this way, so clockwise is positive. Yeah. So we can write this Ry term is making it positive because this is a clockwise positive for us. So Ry is nothing equal to mg only. So we have mg times this length from here to here. Yeah. So mg times L. So from here to here is L theta. So mg times L theta is the positive or the clockwise, minus this is negative. So Rx times what? From here to here. Distance from here to here. Distance from here to here is L only. Why? Because theta is very, very small. So L cos theta is equal to L only. Yeah. So we get Rx times L. Yeah. Okay. So this clockwise minus Rx like this one. Okay. And has to be equal to Gj times theta double dot. Yeah. Okay. Or mg L theta minus Rx value we can put from here, and Rx value is m x double dot plus L theta double dot. So this is mx double dot plus L theta double dot, this Rx times L from here is equal to J G theta double dot. Yeah. And hence what you get? You get this equation. Finally, J G theta. Okay, we write like this: J G, okay, plus M L square theta double dot. So this gone this side, plus we write plus here, plus mx double dot, right, minus mg L theta equal to 0. So all gone this side. So this is one equation, right? Okay. Here in terms of x we have theta, m is known, L is known, gj is known. Sorry, jg is known. So this ml square you get from there, and this is how it is, right? Okay. Now this equation we get for this one. Yeah, and we have used all these equation. So with this we have used this one, we have used this one already. Final equation is this one, which is for this bar. Now this, yeah, and for this one is what do we have? We have simply the what is the force? Force is simply this one Rx, which is backward, right? So here since Rx is like this one, yeah, so here it will be backward, and what we get minus Rx will be equal to mx double dot, where where Rx is this, right? Here Rx is this, or simply we get mx double dot plus Rx equal to 0, or mx double dot plus Rx is this, mx double dot plus L theta double dot, right, is equal to 0, or simply m plus big M plus small m x double dot plus m L theta double dot equal to 0. We have this, not 0. Okay, sorry guys. There is a force F also here. Yeah, remember that. So we have F minus A minus Rx has to be equal to like this one. Yeah. So we have this equal to F, and here also equal to F, and here equal to F. So these two equations are important. Once you have equation, you take Laplace transform, and the output will be theta, input will be F. You can the x you can remove. There are two equations. There are two unknown x and theta. Yeah, so you can remove one of them, and you will have finally F in terms of theta only. Got it, guys? Main thing is find out this equation. Once you have this equation, you are done. You can write this also as a. I'm going to remove this part. So the final equation will be like this: m plus big M plus small m, ml, right? And you have just guys here. It looks like there's some problem. It should not be like this. Okay, so we have m times L here. See, so m times L has to be there. So like this. M times L here. Okay, because here m is there, L is here. Okay. So ml here, we will have ml here as well from here, and then you have jg. Yeah, so J is nothing but 1 over 3. So 1 over 3 ml square plus ml square. Yeah. 1 over 3 ml square plus ml square will be there. And then you have x double dot theta double dot plus. So this is the equation. Plus we have in terms of theta, you have just this one only. So you have in this you don't have. So equation 0, 0. In this you have in terms theta only. So 0 minus mgl x theta equal to f 0. So this is what the equation you get from it, right? So what you see from here is a mass matrix. If you want to relate it with the vibration class multi-degree of freedom system, yeah, and you have k here, and you see k here is negative, and that makes it unstable, right? That tells you that it is not going to be a stable. The stiffness is negative. That's it tells you. Yeah. So, and hence you have to make it a stable. That's the idea. Yeah. So got it? Okay, B22 G1 power should be a split R in some ratio, or take R times G1 should be treat R as current as input R or voltage as input. Okay, so let me see now B22. From problem with G1 power should be a split R in some ratio, or take R1 times G1. Okay, should be treat R as current as input R or voltage as input R. Okay, now R you have to take as voltage basically. So it's, yeah. So okay. Remember that whatever the, let us say B2 2. So like you have G1 here, and you have goes like this, right? So and so on. Okay. So basically here, if it is R is there, RS. So these are not current. Okay. Remember, this is the state. This is the same state basically. What it tells you what is the value. It is not a circuit. Okay. So this is not an electrical circuit. Remember, not an electric circuit. RS will be something like a potential or voltage. Yeah, so if you want to relate with electric cycle, it will like voltage only. So whatever the value here is the same thing, RS only. Here it will be RS only. So same value will be both there at both the places. Yeah, because it is not electric circuit. Otherwise, what like in electrical circuit, you have so what we get basically is in this case, are you with me, guys? Are you listening to me?
Yes, sir. But sir, I request you, can you please solve this whole question?
Yeah.
Second.
Okay. Sure. Okay, so let me draw it. So we have this, and after that we get G2, and here we get CS. Okay, and then we have like going like this, and then we have H1 here, and then here the H2 here. Plus minus here, and then it goes to here like this. So H1, H2 plus minus here, then you get plus here, G2 here, G1 here, plus minus RS like this. That's all. Okay, we have to find out CS over RS. Yeah, that's what we have to find. Okay, so how to solve it? Basically, the idea is wherever the signal is known, right? Signal means basically this is signal. You can say signal only, right? So wherever the signal is known, you will just write in terms of that. So you know that it's coming like this. So this point is here. It is going like this way. Then this is backward, the feedback. So CS here. So CS is here as well. CS is here as well. CS is here as well, right? And then what is the value here? H2 times CS. H2 times CS. What is the value here? H1 times CS. What is the value here? At this point, this added, this will add, this is subtract, H1 minus H2. H1 minus H2 CS. Right? So H1 minus H2 CS. Okay, and then it will go here, and from here you have RS here. What is the value here? G1 RS. Yeah. What is the value here? RS. Here the value will be RS minus this, minus H1 minus H2 CS. Right? Because RS comes from here, H1 minus H2 comes here, right? Okay. What is the value here? Here it will be G1 RS, right? Plus whatever this is, right? Plus RS minus H1 minus H2 times CS. Is like this one. And what is the value here? CS, but basically G2 times this one. So what we get is G2 times this value should be equal to CS. So G2 times G1 RS plus RS minus H1 minus H2 CS. The whole thing multiplied by G2 has to equal to CS. So this equation you have, and this you have to solve. So what you get here? G1, G2, RS plus G2, RS minus G2, H1 minus H2, CS equal to CS. This will go that side now. What do you have? RS G1, G2 plus G2 is equal to CS multiplied by 1 plus G2 H1 minus H2. And hence, CS over RS equal to, this tells you that CS over RS is equal to, CS over RS equal to this. You have G2 plus G1 G2 divided by 1 plus G2 times H1 minus H2. So this is the answer. Got it? So basically for you, RS is given, for you CS is given, and you are working backward from this side also, you are working forward this side also, so that finally you have to relate somewhere. Somewhere you will see that the CS and RS from this side and that side has to be matched. So here only typically will get at the end, we will have both the sides which has to be matched in values, and you solve them and you get CS over RS equal to this, and this is the closed loop transfer function. Clear? Okay, the RS is obtained by Laplace of current function or the voltage function. We should just consider it as a signal only, solve it some way only. It doesn't matter are obtained from current or voltage. Is that is correct? Sudesh, that is correct. Okay. For you, when it is a block diagram, diagram does not tell what kind of problem it is. Whether it's current, the electrical problem, mechanical problem, or what kind of problem. Yeah, here it relates the input and output, that's it. Yeah. So and in current also you see that the input out typically the final relationship between the input voltage and output voltage only. Typically it's like that. Yeah, but in any case, block diagram means it is not electrical engineering problem. It is just that the value of the state of the signal. Yeah, and so basically there is a state here. What is the value here? What is the value that way? The signal, the value of signal itself. So you can you don't have to think about whether it's coming from current or from voltage or from anything. Never think in terms of that. Here RS could be the torque, right? You are giving an initial torque here, and CS could be a final theta that is moving. So and rest all this could be some gearing or some kind of system. How do you know? Yeah, so what you are saying is correct. Any other question, guys? Any other questions? Okay. So the idea is to solve yourself, guys. You know, even if it takes long, when you solve it, you will actually, first of all, will feel very happy that you have solved it. Number one. Second thing is, solving problem itself is the most effective way of learning. You know, and nothing new. You know that from JE also. More you problem you solve, and more the fundamentals are clear. Yeah. So same thing in this case. So your textbook is also a nice textbook. It has a lot of examples solved. So you can also do like first solve the example, the solved example only. Don't look at it. Don't look at the solution. You solve it and then see how they are solved. And during live session, of course, I can help. Yeah. So, okay, guys, if there is no more questions, okay, thank you. And we'll see you next week. Okay. Bye.